Welcome to Lesson 2B, which is all about expressions and assignments in Python. I think you're going to find that this is going to be a fairly simple lesson, especially if you remember how you manipulated variables, did arithmetic with them, assigned values to them in other languages that you're familiar with, like Java or C++ or JavaScript. Python works in a very similar manner to the others. I'll point out what's different and give you a bunch of lists in this PowerPoint that you might want to refer back to. You can also get this information, of course, from the Python docs if you go to the help menus from within IDLE. So let's get going on expressions and assignments. You remember from our 2A lesson that Python has numeric types, either integer or floating point. Regardless of whether they're integer or floating point, if you've got numbers, you can do numeric operations on them. Here's a list of some of the ones that you're going to find most useful. And for most of them, they're exactly what you would expect. X plus y adds the number x and the number y. X minus y to subtract. X with the little asterisk that you get from the uppercase of the 8 for multiplication. Here's something that's different. There are two different divide by symbols in Python. If you do x divided by y with just a single slash for the divide by sign, it divides x by y. It does true division. It always produces a float, no matter what the inputs are. If you do 3 divided by 4, it gives you 0.75. If you do 1 divided by 2, it gives you 0.5. If you do 9 divided by 3, it gives you 3.0. Even if you're doing your division with integers, it will give you a floating point answer so that nothing gets lost. If you want to do integer division, which is the default for almost all other programming languages, you do x / y. That divides x by y, and it truncates any fractional part, so it always produces an integer result. So for example, 5 divided by 4, if I do it with 2 slashes, 5 / 4 is just the integer 1. If I do it with 1 slash, 5 divided by 4 is the floating point number 1.25. Okay, the percent sign gives me the modulus, or the remainder, of dividing x by y. So 7% 4 gives me a 3, because 7 divided by 4 is 1 with a remainder of 3. Something that we use this for a lot in Python is, can you tell if something is an even or an odd number? If you do, say, x% 2, if x was an even number, x% 2 will give you a 0. If x was an odd number, x% 2 will give you a 1. That's very useful if you want to have some processing in your code, that the first time through the processing it does one thing, the second time it does something else, then it goes back to doing the first thing again. You can raise to a power by using the asterisk twice. X * y takes x raised to the y power. So if you wanted to do x cubed, you do x * 3. You can also do that with the POW, the power function shown towards the bottom of the list. POW x, 3 is the exact same thing as x * 3. I can use a minus sign to negate the value of x, or I can use it as in above to subtract one number from another. This is exactly the way you would do it in math notation and on your calculator and in any other programming language you've done. Plus x you can put in, it doesn't do anything, it just says replace x with x. So it doesn't do anything, but sometimes we'll use that in our programs just to add readability. If you want the absolute value of x, that is, change all negative numbers to positive, leave positive numbers and 0 alone, you do ABS parenthesis x. That's a built-in function that you can use with any numeric. We already talked about POW. And the round one rounds x to n decimal digits. So round of 4.6732579 to one digit would be 4.7. Suppose x and y are string variables, not numeric. Well, now the plus and the times symbol mean something different. X plus y concatenates string x and string y. Let's say x had the value, quote, hello, quote, and y had the value, quote, Mr. I, quote. X plus y is the string hello, Mr. I. X times y, if x is a string and y is a number, we'll take that string and repeat it y number of times. So if you had, quote, hello, quote, times 7, that would be the same as if you had the string hello, 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 hello. I think that's 7 times. And then the built-in function len, length, len, parenthesis, a string variable name, gives you how many characters are in the string. So len of quote, hello, quote, would return a 5. Suppose x and y are logical operators, or x and y are logical variables. That means they're true or false. There are some logical operations we can do with the values true and false, and, or, and not. And they work just the way they do in math and in every other computer programming language. X, and then spell out the word and, all lowercase, y, means perform the logical and on the values x and y. True and true will give you a true. Any other combination will give you a false. X or y. True or true is true. True or false is true. False or true is true. False or false is false. And not x just gives you the opposite. Not true is false. Not false is true. There are 6 comparison operators inside of Python, and these are the same as in many other programming languages. If I have 2 values, whether they're numeric or logical, Boolean, or string, I can compare them using greater than or equal to, less than or equal to, equal. Notice it takes 2 equal signs to compare something on the left to something on the right. A single equal sign does not do that, and that's a real common programming mistake in Python and in very many other languages. X equal y tells you, do these 2 things have the same value? If they do, it's true. If they don't, it's false. And then X exclamation mark equal y, that's the not equal to sign. We'll use these a lot when we get into our if statements in our next lesson. Now, how do I assign values to a variable? We saw some of this in a little bit of the playing around we've done in idle. X equals y. Notice here I've got a single equal sign. It says take whatever the value is on the right of the equal sign and put it into the variable on the left. Now the right-hand side doesn't have to be just a single variable. It can be a complicated expression. X equals 17 plus y times a raised to the 3rd power minus 42.7. It'll do everything on the right. Whenever it's done with everything on the right and has a value, it'll put it into the variable on the left. X plus equals y. I've put the plus sign and mashed it right up against the equal sign, is the exact same thing as saying that x equals what x used to be plus the value of y. A very, very common expression in Python. X plus equals 1 means increment x by 1. X minus equals works the same way. X times equals works the same way. X divided by equals works the same way. X percent equals works the same way. They all, if I put the operator right next to the equal sign, are equivalent to saying x equals x and then the operator. Now let's talk about type conversions. When you perform arithmetic operations that involve both an integer and a floating point number, Python automatically converts up. It will change the integer to the floating point, because floating points can contain more information than an integer before performing the operation. So if you're adding an integer and a floating point, it'll convert the integer to a floating point, add two floating points, your result will be floating point. If you're adding two integers, it doesn't do that. 6 plus 5 is the integer 11. 6 plus 5.0 is the floating point number 11.0. Now, Python will convert numerics automatically. It will not automatically change non-numerics to numeric. So if I have x equals 4 times 4.5, that's an integer times a floating point. It will turn that into a floating point times a floating point, and you'll get an answer of 18.0. If you have the character string 4 times 4.5 and try and multiply it, even though you know what you wanted, you said, hey, the number 4 times 4.5, that should be 18. No, Python says, I can't multiply a string by a number. A string with a times sign, that's not going to work. Now, if I had quote 4, quote, times the integer 4, remember when we talked about our string operators, that would just repeat the string quote 4 times. So that would be 4444. We're going to get into idle in a little while and play with some of these things, and I encourage you to do the same thing so you get used to what happens when you manipulate things. Using the shell in idle is a great way to see what's going to happen if I try this in my program. There is an operator precedence in Python, and we're not going to spend much time with it. There is an order of operations that's just like the standard arithmetic order of operations. Raising something to a power, exponentiation, happens before any multiplications and divisions, which happens before any additions and subtractions. Within any group, it goes from left to right. When in doubt, use parentheses to group expressions. If you do x equals 6 plus 12 divided by 3, well, Python says, I have no problem with that. I'm going to do the division before the addition, and I'm going to get 6 plus whatever 12 divided by 3 is. Clearly that's a 4. 6 plus 4 is 10. I would encourage you, even if you know what Python is going to do, put the parentheses in so it's obvious to you, the reader of your program, what Python's going to do. You can change the order of operations, or the order of operations might not change. Put the parentheses in, Python will do exactly what you tell it. Y equals parentheses 6 plus 12 divided by 3 says do the addition first. 18 divided by 3, that will have a value of 6. Here we are now in the Python shell, and we're going to do just a little bit of playing around with some of these operators. I encourage you to do some playing around yourself before you get to this week's programming assignment, just to make sure you know what's going to happen when you try these things. Let's do some of the numeric operations first, and let's give ourselves some variables. Let's say x has a value of 15, y has a value of 4, and z, let's make z a floating point number of 10.3. So let's try some addition. X plus y. Notice something that I don't think I've shown you in the shell before. If I just put an expression here in the shell, it gives me back its value without me having to say print. That won't happen from a program. If I just put x in a program, nothing's going to happen. But if I put x in the shell, it says you must have wanted to know what the value was. That's the same thing as if I did print x. So it makes playing around in the shell pretty easy and convenient. So notice when I did x plus y, two integers added, I got an integer. X minus y, I'd expect that to be 11, and it is. X divided by y, Now I get a floating point number. 15 divided by 4 is 3 3/4, or 3.75. But if I do x divided by y with 2 slashes, I get a 3. If I do x divided by z, I get 1 point all of that stuff. But if I do x divided by z with the slashes, I just get 1. Notice, since z was floating point, my answer is floating point when I do x divided by using the integer division and the z. I got an integer when I did x//y, floating point for x//z. Okay, let's just try something like, what's the absolute value of negative z? It becomes whatever positive z is. What's the absolute value of just z? 10.3. Let's do the percent. X percent 2, that's an odd number. I should get a 1. Y percent 2, the remainder when I divide by 2, I get a 0. Try some comparisons. X greater than y? True. 15 is bigger than 4. X greater than z? True. Z greater than y? True. Z equals y? I've used the wrong equal sign. What have I done? I've put the value of y into z. Z is now an integer. That isn't what I wanted. I'm going to go back and put a floating point into z. Z equals 10.3. And try z equals y. That one's false. Z equals 10.3. That one's true. Let's play around with some strings now. S equals HO. S times 8. S times 8, not X times 8. Ho, 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 ho. Okay. How about S is ho. Let's make T equals hi and do T plus S. Hi ho. T plus S times 5. Hi ho, 5 times. Okay, enough playing around with strings. We've done comparisons. Let's do a little bit of logical work. Let's get a variable L1 equals true, L2 equals false. Do L1 or L2. True or a false is true. L1 and L2. That one's false. Not L2. Since L2 was false, not L2 is true. Let's do some assignments. We've done some of these by accident already. X equals 7. X now has a value of 7. X plus equals 3. X now has a value of 10. It took X and added to it the value of 3. Notice there's a difference between X equals 3 and X plus equals 3. I can also do something like X times equals 10. Now I'm going to get 10 times 10, or 100. Let's see, is there anything else we ought to do? Let's try a string that looks like a number times an integer. Okay, I get 5555555. A string times a floating point number. Oh, error message. I can't multiply a string and a number. And let's do a little bit with our operator precedence. X equals 6 plus 12 divided by 3. It'll do the division first, so I get 6 plus 4. X has a value of 10. Notice it's a floating point 10, not an integer, because whenever I do division, I get a float. 12 divided by 3 is a float. When I add that float to the 6 integer, Python will up convert. Oh, an integer and a float, I'll make them both floats. Now, if I do x equals 6 plus 12 divided by 3, and I put the parentheses in, I get the exact same value, because that's what Python would have done anyway. Suppose I put the parentheses here, 6 plus 12 divided by 3. X now has a value of 6, no longer 10. Okay, play around with some of these until you know how they work, and you're ready to move on to lesson, I think we're up to 2C, if statements.